let L be the length of the rod. Already we have some idea of motion. A moving rod, shall we treat like it's a cell of EMFE? Let me minimize the diagram a little bit. Yeah. Very next moment, what do we get? The position of rod, the inductor will be there. The position of the rod is going to change. No? So the rod, let it be somewhere here. So this will be the position of the rod. Then flux, negative flux increases by Lenz's law. Negative flux into the plane. So B bar into plane negative flux. As the rod moves towards right, negative flux increases defined negative EMF induced positive. How the induced current will flow anti-clockwise. Then let the rod have velocity v. Then BIL force will act towards right. So the rod will undergo retardation. Then the decrease in kinetic energy of the rod, where it will go? Get converted into increase in the flux, magnetic energy inside the inductor. So let me put plus. The question is very important, basic for oscillations through inductor. That's why I just picked up this problem now. Because of BIL force, the rod will continuously will undergo retardation, and finally, so it has to come to rest, instantaneous rest, you can better say. Let's take this one. So fine. Now, what is the position of the rod? Rod will be, it undergo retardation and let it come to rest here. What happened? All the energy, the whole energy here. What was the energy in the inductor? 0, and the kinetic energy is maximum. Now both UL non-zero, kinetic energy also non-zero. Now kinetic energy of the rod is 0, no, but UL is maximum. All the energy, kinetic energy of the rod given will be stored in inductor. After this, what will happen? There's the maximum energy stored in the inductor here. So now there is no, and this moving rod was being like a cell, and it has come to instantaneous rest here. No, shall we stop the problem here only? Now, if you look at further, there won't be who was responsible for flow of current, a cell. Keep that in mind. That one. This EMF generated in the rod PQ was responsible for flow of current. Due to that current, here there's a magnetic field is set up. There's a flux is generated, and there's the energy. Now the moment rod comes to rest, why rest? Because BL force is acting opposite to ampere force acting opposite to velocity of the rod. So for a while it will be at rest. For an instant it will be at rest. Then there won't be EMF set up in the rod to support current. So what happened to this flux? The flux starts collapsing. What direction the induced current I should send? In the same direction. The induced current should be in the same direction. The inductor should push. Now it will behave like a cell. No, it will push the current in the same direction. So I'll show that one diagram. It will be like this. So now here only I'll show it. This is very important for you. The current will flow in same direction. Who will support current now? The inductor starts supporting current. Because of this current I, what should happen to the rod PQ now? It will start moving. Sir, how do you can say? By Lenz's law, the direction of induced current here should be such that it should be in the direction of the initial current that was flowing through the inductor. Can you remember I took some loop, one turn, then I showed one initial current, then due to Lenz's law, the direction of induced current should be in the inductor when it's decaying, will be in the same direction of as that of steady state current. So that's all here. So now the flux and BL force, now will the same BL force will act in this. Now the rod will start accelerating. After some time, see, you have to, by this time, I think you might have seen, rather than some just mere mathematics, no, please do end up with the analysis. What will happen for the rod, for one oscillation, what will happen? Because more than one option, definitely they will test students in this way. Anywhere in between also, some conditions based questions can be asked here. So this will have velocity V, acceleration, still the current will flow like this. So what are the, here UL is maximum. No, UL will be non-zero, K will be non-zero. Finally, it will return back to the initial position. Last one more diagram, we'll put it. So this will become off cycle. Finally, where the rod is in, will return back to its original mean position. Here it will have its velocity same. Then what is the energy in the inductor? Will be zero. This what happens in one cycle. This is half of the cycle I'm showing it. This is at t equal to 0. This is at t equal to t by 4. This again at t equal to t by 4 only. To show that the flux across the coil starts collapsing, then this is at t equal to t by 2. Here what is kinetic energy? Maximum energy in the inductor will become 0. No. Again, what this rod will do? As it starts moving towards left,
Sir,
yeah.
the same current will be induced again, sir.
Which one?
The second step, when all the flux started collapsing, then same current will be induced again, sir.
Yeah, it will be just at that particular time how much of current was flowing, the same current, and it starts decreasing gradually. I'll give expression for that. Mathematically, I'll give expression. I'll give mathematical equation so that will be easy for us. Now there's a mean position. So every time I'm drawing, so this that mean position. It will be on the right side of the mean position. How the induced current should flow? The velocity of the rod will be like this. Now negative flux decreases, d phi by dt positive EMF induced nature. The induced current will be like this. The magnitude of current will vary harmonically. That I'll show mathematics rather than pointing here. If I write I1, I2, I3, you'll get confused. So let me just put same I. The BIL force will act here, and the retardation of the rod will be like this. And finally, it'll go to the left extreme, come to infinite rest. Again, it will push. So like this, what is the state of the rod? Rod will be oscillating. is going to describe to and fro motion. So I'm just asking you find the time period of oscillation. This is very important. The rod is moving now towards left here. This is PQ. This is the mean position. The blue color, what I took, that's the mean position. So we have to get the time period of oscillations of the rod. So here again, if you check it, UL non-zero, K non-zero. At left extreme, it will come to instantaneous rest. Again, what happens? The current will try to flow in same direction. And finally, it will come back to, after left extreme, again it will come to this one. So I think I've shown enough diagrams. You further follow the diagrams. Okay, with this much of idea, we have to find out the time period of oscillation. I think enough diagrams are there. This one. So how to get the time period of oscillations? So let's directly go for the formula. What is the force that is acting? F equal to minus me. Then this F should be equal to what is I? I is what? Can we write E by R? Because there are no resistance in the circuit. So as at one place I just shown, like it will behave like a cell. So whatever EMF induced and across the rod should be equal to potential drop across the inductor. So will I agree this? Because they are parallel, no? This will be. So the EMF induced should be equal to this much. So this is equal to BVL. Now what is this? Is L di by dt. Magnitudes I'm equating. So further this dx by dt L length. This is a small l is the length. Capital L is self-inductance. Look at the diagram. I'm correlating with this one. So dt get cancels. So we'll eliminate dt. So I do get now expression for di is equal to bl by capital L into dx. Let's integrate this 0 to I, 0 to x. So what is the expression for I? I equal to blxl, blx by capital L. This value of I, I'm going to substitute here. So there's a method of calculating I as a function of x. This I'll substitute here. B small l, capital L, x small l equal to minus ma. So look at this now. B square L square m by small l capital L. Acceleration proportional to negative of displacement. So what is omega? So time period of oscillations is 2 pi ml by b square L square. So this is the time period of oscillations. What's happening to kinetic energy? What is the role of BL? BL is like some sort of agent which will convert mechanical energy into magnetic field energy into mechanical energy. That's the role of BL. I think the BL is really playing a, it can convert mechanical energy into electrostatic. It can convert electrostatic into, what is the role of it? It will just convert energy from one form to another form. What about the other things? I want expression for, say, some quantities like M is not mutual inductance. Now, what is capital L? Self-inductance. Means now, this L is what we have introduced. So any current carrying loop will have inductance as you can bring also self-inductance of the loop, and that will be variable. Therefore, I just brought L is the external inductance what we calculated. What we have to say, neglect self-inductance of loop. Not this L. This is the external inductor. We have brought it. This loop, current carrying loop, flux linking the loop to the current in that should be self-inductance. These wires also will offer some self-inductance. So that we are neglecting it. So they may trouble you in exams keeping that in mind. This is the external inductance what we brought. Self-inductance also will come into picture. You have to be careful. Any current carrying loop will have self-inductance. If two loops are there, mutual inductance. This is a very general. Now you have to accept and carry on in the numericals. Expression for speed of the rod. I want the speed of the rod. Can we
Not
write
cos
any?
omega.
So can we write any energy equation? mv naught. See, like try to develop this. mv naught square by 2 equal to mv square by 2 plus li square by 2. Now look at current. Current is at and what is x? X is equal to a sine omega t. Shall put it here? And that v naught is maximum, and v naught what you can write a omega. The problem is not yet over. I can ask you another for 1 hour. I can discuss only this question. Why a sine omega t? Because at t equals 0, we gave velocity, no? If I differentiate, put there, I should get velocity on that one. This is x equal to a sine omega t. In this one. So now you know x, substitute that value of x here. You'll get I. Substitute or now differentiate this. Put t equals 0. If you put t equal to 0, so there should be the a naught omega. So therefore this, I'll write it, v naught cos omega t. So what is the amplitude? Can we calculate that amplitude? What is the maximum displacement? That a naught is maximum displacement, maximum displacement of rod PQ from mean position. That maximum displacement only what we call amplitude, no? How to calculate amplitude? We know what velocity we are given, v naught, and omega what we know from this. I'll get the amplitude. Okay, go this. So now, so what about the current at any time t? Yes, I can bring expression for current also. And the current varies harmonically. So I may ask you some graphs also here. So what's happening to the current here? Current oscillates. It's a electrical oscillations are set up in the system. Already we have seen with capacitor, no, this with inductor. Electrical oscillations are set up in the system. So that's one best example to learn before entering LC oscillations. As we can take help of this basic problem. Okay, listen. Okay, now we'll go for the LC oscillation. Now instead of this rod, say why I'm bringing is, now I'll bring this motional EMF even in LC oscillations. So tomorrow when we discuss some application problems, you can see that.